morning, everyone, and thank you for joining us today. So we'll get started. First off, welcome to Dominion Over Domains. This is a first in the event series brought to you by ACM and ACM-W AACB. And this event is just an introduction about the different technical domains that you can pursue as a career in engineering, and you learn what they are and what they entail and the possible job opportunities you get from each one. And before we get started, my name is Sunil. I'm the ACM chair and I'll be a moderator for today as well. This event is in collaboration with GDSC, ACB, and our speaker for today will be Aravind V Nair, the former Google lead of ACB. So before we go any further, let's just see what GDSC is about. So Google Developer Student Clubs. It's an initiative started by Google that that allows collaboration with university students worldwide who are passionate about growing communities where people of like-minded mindsets about technical domains and technical aspects of things and passion come together and start communities on the campuses like we have here. So this is the local chapter for Amrita School of Engineering, Bangalore. And GDSC has a wonderful vision, their prime target being helping students who have difficulties converting their or translating their academic knowledge to practical knowledge and letting them build something real that will make an actual impact. And this is done through various ways, such as organizing workshops, meetups, coding challenges, and a plethora of other events, a sample of which you'll be seeing here at our local chapter. So keep an eye out for them as well. Now about ACM and ACM-W, a little bit about both the clubs. At ACM AACB, there are three types of events conducted. They are general events, talks and seminars, and SIGs. The SIGs are the primary focus, or you can say the spotlight of the both clubs, and they stand for special interest groups, which are basically, you can think of it as a community where like-minded people come together to learn about a certain technical field that they're interested in, and we hope to give them enough knowledge to get started out and explore on their own after they leave this term. General events include events for everybody, all the audience, and they range from beginner to advanced level in terms of difficulty. And talks and seminars are, well, as the name suggests, they're talks and seminars by various people, industry experts, alumni, our own students, on different topics such as how to how to present presentations, or how to overcome fear of public speaking and things like that, that will help you further your skills or further your career in the tech domain, not just technical skills but even soft skills as well. And specifically ACM-W, we focus on women empowerment and women encouragement in the technical field. We help celebrate, inform, and support women in computing by holding specific events just catered to them, so they can practice in their own space and then be ready to be ready to come back into the actual world and start making a proper impact. And as I mentioned earlier, this is part of a series of events we'll be conducting for the rest of the month. And this is the rest of the itinerary. Next week, the same time, on 23rd, we have Learn Code Repeat, where we'll be spreading awareness about various coding and course platforms that will help you learn code and how to practice it and get better at it, so you can find a footing in a certain field you feel comfortable with. Then at the end of the month, we have Git set, commit pull, where you'll be introduced to the world of version control systems and possibly the most famous interface for one of them, GitHub. And you'll learn to set up your own GitHub account, learn a few basic commands, and even get started on your own code repositories, or learn how to get started building your own repositories so you can showcase your talent in the future. And finally, on the 7th of November, we have Stay Connected, which is an event about LinkedIn and how how to get started there and how to get familiar with the interface of LinkedIn and learn about experiences, the best practices. And this will again be a two-parter, the first part being taken by us, and the second part we'll talk about resume building, which will be taken by GDSC again. So let's meet our speaker. Over to Aravind.
Hey everyone. Am I audible?
Yeah, you're audible, Aravind.
Okay. Yeah. So thank you, Sunil. Hey everyone. I'm Arvind. I'm although we couldn't meet face to face, I'm glad to be here. Before we get started, I'll give a quick intro on me, a disclaimer, and explain the purpose of this session. So about me, I currently work as an AMS Operations Associate Level 4 at Amazon Web Services. I am also the former Google DSC lead for Amrita School of Engineering, Bengaluru. I graduated from the same with my bachelor's degree in computer science and engineering just a few months ago. My primary interests lie in full stack development, cloud computing, and cybersecurity. So that's a brief intro on me. You can look me up on LinkedIn as well if you wish to. And I'll just put my LinkedIn profile in the chat window. About the disclaimer, although I have ties with Google and Amazon, all opinions are of my own. I don't represent either entities today, just mentioning for legal purposes. So coming to why this session. So many people are confused as to which domain to pick, and many times what happens is people tend to pick the domain at the nth moment. And some people like just go with the flow and only start picking domains once they join a particular company. So when you're doing any particular task early or in advance, you're saving that much more time. So the purpose of this session is to give you some clarity on what are the different career paths and what are the different domains available for you to explore. And this applies equally whether you're going towards masters or if you're going towards a career. So do note that I won't be going in detail, as the purpose of this session is just to give you an insight about what a particular domain is about. So I would be covering what exactly a domain is about, but I wouldn't be going into complete details, as then this would become like an entire day session. So before we move on to the first domain, like something that I mention a lot to people is like your first year is your time to explore, because that's when you have the most amount of time. And if you spend your entire first year exploring the different domains of your interest, in this case, this is computer science. So that give you an insight about what are the different possibilities, what are the different career opportunities, what are your interests. You would be able to understand once you start exploring. So if you spend your entire first year exploring, then you could spend your second year working on projects. So maybe let's say you pick like some 2 or 3 domains out of everything that's available by the end of your first year. So you could work on projects in your second year. So what that means is that you know which direction to head in, because until then you have no direction. And that sense of direction gives you a motivation as well, because then you clearly know what exactly you want to do. And if you spend your second year working on projects, that gives you experience, and which is very valuable. And that's the most valuable thing, especially since colleges are taking part of the theoretical aspect. Like what is more important is the practicality. And since they are doing that part, you can do your part, which is the practical exposure. So if you work on your like projects in the 2 or 3 domains that you picked during your second year, that would give you experience to apply for internships. So during your third year, when you're going up to companies and saying, "Hey, I have so and so experience, could I get an internship?" They would be more willingly, they would be able to give you the internship, because compare that to someone who doesn't have any experience and they're just begging for internship. That's not how it works, right? And likewise, when you do internships in your third year, when you come to your fourth year, if you have the time, you could work part-time. And if you don't have the time, you could keep applying for full-time jobs, which should only start after your fourth year. But you could spend your fourth year doing that. So, and there too, like you can show how you have project experience as well as the internship experience, as well as how you were exploring in your first year. So these are like proofs, because when you have proofs to show, your I mean, it shows that you're more capable, and like everyone can understand why exactly to pick you. So even if you look at my LinkedIn profile, for example, you can see I've clearly listed everything that I've done. So if you properly, follow this kind of a structure, then you too would be able to build a resume or even better than mine. So yeah, so that's enough said. So let's get started with the first domain. So let's start with cloud computing. So the whole purpose of cloud computing was to move everything to like a large scale computing infrastructure. So typically what we used to use was something called on-premise, wherein whatever computers or whatever servers that you're using were in one specific location within a building. So let's say, for example, you're having an office, all your servers and everything would be within that building. But now, let's say something happens to the building, your servers are gone. Instead, what cloud computing does is it splits all your resources across a region. It could be in a single continent or it could be across multiple continents. There are different ways to do it. But cloud computing is all about taking something that's on-premise and putting it in the internet and spread across different locations. And there are various applications to cloud computing. It's not just basic barebone servers. There are machine learning applications. There are a lot more things that you can do. And especially considering that cloud computing has so much more resources available to it, it makes machine learning, data science, and such kind of things much more quicker because you have that much more resource to spare. Also, another main important factor is that when something is on premise, you would be spending a lot of time trying to, fix things on your own. And also there's the cost involved, especially the electricity and things like that. So with cloud computing, with the servers sitting on the internet managed by someone else. So for example, Google Cloud platform, Amazon Web Services, Microsoft Azure, these are like three popular things three of the biggest cloud computing players. Apart from that, we also have IBM, we have Oracle, and we have so many other companies as well. And so there are different services that are provided. So that's what is mentioned in the slide as well: SaaS, PaaS, IaaS, and anything as a service. So software as a service, I'm pretty sure all of you have used at least one form of this. So software as a service, for example, is Gmail or Outlook. So it's like you're using an application in the web, right? So that's software as a service. And platform as a service is basically any platform where you can deploy something very easily. So and it could be something where you can manage stuff, or it's basically a platform for you to do a particular task. That's what platform as a service is. So for example, GitHub. And infrastructure as a service is like you renting servers or you getting hardware. And for example, you could say GCP is infrastructure as a service because they have cloud computing services and they're allowing you to rent particular hardware based on what your requirements are. So another thing that comes up with this cloud computing is, I mean, considering the massive scale or the infrastructure, it becomes easy to even prevent, denial of service attacks, which is quite a common cyber attack which happens on a regular basis. So rather than all your traffic being congested in one single node, you're able to spread across it in like multiple nodes. So that way you're even less susceptible to cyber attacks. And so yeah, there are various benefits to cloud computing. This is just a brief overview. And as for the roles, there are different roles such as cloud architect, DevOps engineer, data engineer, and there are so many more. And basically, certain roles are all about how to build infrastructure in the cloud. So, for example, that's what a cloud architect does. And on the other hand, if you're something more specific, like DevOps engineer, for example, then you would be, sitting with just DevOps in the cloud. What is DevOps? I'll come to that in a moment. And the coming to the types of cloud computing, you have public cloud, you have private cloud, and you have hybrid cloud. So companies, if they are, usually okay with things, they would be in public cloud, where especially in startups and things like that. So public cloud is what is generally accessible to the public. So for example, GCP, Heroku, uh, AWS, Microsoft Azure, all these are public clouds. On the other hand, if you're building your own internal thing, that's what you would call a private cloud. And just a mix of these two is what you call a hybrid cloud. So the main advantages of cloud computing is that it gives you a lot of resources and it is pay as you go, and there are no upfront costs as such. So that way you're getting a lot more resources, you're saving a lot of cost, and in many ways it's also more economical and environment friendly as well. So that's all about cloud computing. And before we go on quantum computing, I'll just share few resources in the chat window through either after the session or parallelly as well. So yeah, these are few sessions on cloud computing. Sorry, a few resources on cloud computing. So yeah, coming to quantum computing. Quantum computing is like, I mean, the traditional way of computing was to, it's based on electrons and it's based on the flow of electricity. Whereas quantum computing is like a very upcoming thing. This is something where there's a lot of research going into, and this is a pretty new domain. So usually, I mean, there are no specific jobs as such yet in this domain. I mean, there are a few people who are working, but it's mostly about research. So this is all about applying quantum mechanics and trying to achieve like massive super, like even greater computing than a supercomputer. So that is primarily what quantum computing is about. And why do we need quantum computing when we have cloud computing? If you ask, they are different because cloud computing is about operating massive scales of computers, whereas quantum computing is all about how the computer is processing data. So typically in the electron, like normal computer, we have this binary 0, 1, which is just high voltage, low voltage. Whereas in quantum computing, you have something called a qubit. And because this qubit is so precise, the amount of memory you can process at any given time is very high. So that's a key advantage of quantum computers over a supercomputer. Because for supercomputers, it's about how much memory you put in, whereas quantum computing, it's all about how well you optimize and things like that. And because of which it becomes really fast. So where are quantum computers used? It's primarily used for scientific research. It is used for, it can be used for weather forecasting. It could be used to test vulnerabilities. There are various applications to quantum computing. Like this is still a very upcoming thing. So the future is, we can only tell a couple of years later. As for the career paths here, as I said, it's mostly a research role. So if you're gravitating towards, masters or things like that, you could go to this. IBM and Google are like two major pioneers in this field, and they've been doing a lot of work, about quantum computing. In fact, Google just recently announced their first quantum computer also, and they achieved something called quantum supremacy. So yeah, this is very new field, but a very interesting field as well. And so yeah, that's about quantum computing. I would give you a few resources about these as well. So I'll put in the chat window. This is quantum computing resources. So coming to the next domain, data science. Data science is a field that it's like a multitude of various different fields. So as you can see in the chart in the top right, you can see how we have domain expertise of a particular domain. We have the mathematics coming into the picture. We have computer science. So various things put together is data science. What is it about? It's about collecting a lot of data and then trying to get as much insight as possible from a specific data. And if that data is in very large scale, we would call that big data, which is a derivative of data science, you can say. And data science is all about, gathering all the data, making sure that the data is correct, clean, and exactly what you're expecting to be. Nothing extra, nothing less. And at the same time, you're trying to get valuable insights about it. So for example, let's say you're collecting data about rain, and with that data, you can do some analysis on that, and then you can figure out which days are raining more heavily, which months are having more rain, and so on and so forth. So that is what data science is about, to give you a simple perspective. And it's all about gaining, uncovering data that might be, not, I mean, it might not be visible straightforward, but with data science, there are techniques that you can use. There are different tools that you can use, there are different algorithms. It's all about uncovering data that you wouldn't, normally you would find, or rather uncovering information that you wouldn't normally find. So that is what data science is about. And as I said, it's a combination of different fields coming together. So there are roles such as data analyst, data engineer, data scientist, and so on. And again, the prerequisites for different roles vary. So that's what you're seeing on the screen as well. And data scientists use statistics and machine learning. They try to predict answers. Data engineers are people who try to up a system, or they try to optimize the data. And they generally go hand in hand with data scientists. Data analysts are basically just people who are just, working from a business perspective. They try to crunch data and they try to get meaningful insights out of that particular data. So all three are kind of identical, but at the same time, they are very distinct as well. And for data science too, I would give all of you a few resources. And this is from IBM. You can check it out. So coming to the next topic, artificial intelligence. So artificial intelligence is all about trying to make computers think in like from a human perspective, because we have different senses, but a computer doesn't. So artificial intelligence, simply put, it's all about trying to make a computer do stuff that, us humans could. And many people refer to this as the fifth generation. That's also there. And within artificial intelligence, you have various different things such as machine learning, which is about teaching a machine to learn on its own. Then there are things such as natural language processing, deep learning, neural networks, CNNs. There are various different things under this particular domain. So I won't go into those for now. But to give a general perspective, it's all about teaching a computer to think, or teaching a computer to do a specific thing. And again, this is completely on coding basis itself. So natural language processing, for example, it's all about understanding how a particular language is, or what are the syntaxes and semantics of a language. So based on that, you could, do something out of it. So to give you a real example, the autocorrect that you usually find on your phones, that is based on NLP, natural language processing, because whatever you're typing, it is being processed real time, and then based on that data, based on what your typed so far, it's trying to guess what could be the next word. So that is how autocorrect works, or how autocomplete works. And this is purely based on natural language processing. Again, you have things like speech synthesis, or text to speech. So it's all text to speech, for example, about reading the words from with a human voice, but the machine is doing it. And speech synthesis is about processing, like for example, some of you might have said, "Okay, Google," or "Hey Siri," or things like that. So that is speech recognition. And likewise, there are various different things under artificial intelligence. So as I said, this is a very vast field. Again, there are different domains also connected to this. So for example, there's a lot of data involved in artificial intelligence, and that's where data science also steps in, because when you have the right data, it makes the model more accurate, and it can directly performance of your model as well. And again, cloud computing is also something that is connected to various different domains, as I said before. So rather than doing like AI tasks on your system, you could perform things in the cloud, which makes it much more faster and much more performant. So that's about artificial intelligence. I would put a few resources for that as well. And moving to the next domain. So starting with DevOps. So DevOps is nothing but development operations. So previously, what used to happen was that in a company, like some people would be responsible for writing the software, some people would be responsible for testing, call the QA people, quality assurance. And some people would be responsible for documentation, like reporting back of the test cases and things like that. Because basically, whenever you are releasing a software into the market, you got to test properly and see how it is performing or how it is working, right? You don't want the customers coming back to you and saying that is not working, this is not working, etc. So that's why we have this testing processes as well. So what DevOps is nothing but a combination of developer operations. So it's all about trying to automate stuff as much as possible. It is about automating test cases, automating development, having continuous integration, continuous deployment, and so on and so forth. So when you're having automation, it drastically reduces time. That's the first thing. And although you might spend quite some time trying to set up the automation, but the future things will be faster because then it's just a repetitive task. So simply put, that's what DevOps is about. And this can really, improve the speed. It can reduce the time. It also makes everything more streamlined because imagine you have a centralized database which is showing you everything that you need. So from that one database itself, one dashboard itself, you can understand when some test case is failing or if something is not working as intended. And DevOps engineers can, keep watch on such kind of a dashboard, and they can, come back and tell the programmers that, hey, so and so thing is going wrong. You might want to take a look at it. So like that. And speaking of the terms that I just mentioned, continuous deployment, it's all about automatically trying to deploy something because rather than you manually going and deploying something into the cloud or into some server, if you can automate it, so it could be like, your some developers writing some code, it goes into the test case. If it passes all the test cases, it gets deployed automatically into the whatever environment that you need. So rather than manually deploying something this thing failed to pass the test cases. So that's what automation is about, and that's what continuous development is. The testing part, continuously testing, that's called CI, continuous integration. And for this too, I will share few resources in the chat. And yeah, this, yeah, I put in the chat window. So coming to cybersecurity. Cybersecurity is a domain that, just like cloud computing, can be connected with every other thing, and even more than cloud computing actually, because cybersecurity is all about trying to, protect computing infrastructure or protecting a particular thing. It's about how you're going to research into a particular vulnerability, and it's about patching things and identifying things as early as possible. So simply put, that's what cybersecurity is. This is a very vast domain because there are various things such as cyber forensics. There is vulnerability assessment. There is penetration testing. There are various things that come under cybersecurity. And the reason why this domain is connected to every single domain is because take data science, for example, there's a lot of data, and that data could be something that is, private data. It could be something that might contain personally identifiable information, PII, or it could be some sensitive data. So again, there you need cybersecurity because you need to protect data. You don't want the data accidentally leaking somewhere. And likewise, let's say you're making a web application, web development. So again, there also you need cybersecurity because you don't want random people hacking into your web application. And likewise, whether it's software development or you need to do it in some way or other. And that's where, cybersecurity plays a big role, and so does cloud computing, because these two are domains that are, very much interconnected to pretty much everything else, which is what makes it so vast as well. So for example, some people might be interested in becoming a wireless penetration tester. Some people might be interested in finding vulnerabilities in, let's say, a firewall or a web application. And some people might be interested in only targeting mobile applications. So there are various roles and there are various subdomains within cybersecurity. And again, it could be something related to data science. connected to cyber forensics also. Cyber forensics is nothing but cybersecurity in the criminal world. So, for example, cyber police and things like that, they mainly deal with cyber forensics, like trying to identify victims, trying to identify fraudsters, trying to catch them and things like that. So, trying to find an identity trail. So that's what cyber forensics is about. So this again is a very vast field. I will put few resources in the chat as well. And in case any of you have any questions, feel free to drop in the chat. I would pick it up. So coming to the next thing, robotics. Robotics is basically a what do you say? It's a hybrid thing between computer science and electronics, and it's all about trying to again automate. You can automate repetitive tasks, or you can automate stuff that you generally would do. With this automation, again, you're saving time. So let's say, for example, you have a robot that's just going around your house, cleaning up the dust and things. So then you don't have to go sweeping behind it, right? So you can just do the robot do its job. And likewise, and robots are used in many different places. Like, for example, a prominent use case is in the manufacturing industry, where the packaging is done by a robot, or it is even used in the car manufacturing, for example. The robots are what puts together the different car components, although not completely, but to an extent, yes. And Amazon, for example, every time you're shopping from Amazon, there are robots going around in a very large facility that are trying to, pick stuff up from different baskets and different containers, and that's then being brought to a human who then manually handpicks. And again, after that, the packing and then shipping and everything is again handled by robots. So robots are something that uh, are used in a very large scale, although maybe not so much in like a personal use case, but mostly it's in the commercial use case. But that's what robotics is all about. So again, there are different perspective, sorry, or different directions within robotics itself. So maybe some people are only interested in the software application. So in that case, you would be writing code, or you would be writing applications or the interface or some operating system for these robots to operate. On the other hand, it could be from a hardware perspective as well, where you're trying to build up the most efficient hardware or least power consumption and things like that. So again, there are different job opportunities, and there are different directions to look from within this robotics. And this again is something that is interconnected with other domains. Like many of these domains are actually interconnected with each other. So you can't really say one domain is better than the other for that same principle. But robotics, for example, it could be connected to a large scale network where every robot is being monitored. At the same time, robots could collect feedback, or it could collect data and it could send back to a centralized location. So, for example, let's say you have a robot that's going around in the ocean to find chemicals or things like that. So, whatever chemicals it's finding, it could send all that data back via the internet to some central facility, and you could perform data science on it. And once you perform data science on it, like some data science operations on it, you could get some insightful data. You could get meaningful data out of it, and with that data you could come to some conclusions saying that okay, in this part of the ocean there's more chemical concentration which is harmful, and so on and so forth. And based on all that data that you're trying to generate, you could even build up artificial intelligence models which you can then try to predict as to which location might be having something, or maybe you found a particular parameter. So based on that parameter, what is the probability that this place is a dangerous location? So there are different, you know, uh, this is how all the different domains interconnect. And likewise, this entire thing could be hosted in cloud computing environments. So there you have cloud computing. And again, if you're building a dashboard or something to show this, so that's where you have software development or web development and such kind of things coming up. So again, you can see how different domains connect together. And that's also why it's important to pick a specific domain, because you can't work in every single domain, right? You have to pick one or two domains, and then you'll be working with different people in the industry. So that's how it works. So coming back to robotics, that's what it's all about. Again, there are different subdomains, as I mentioned. I will share a few resources for this as well. One more thing about these resources, it's these are all beginner friendly resources, so it's nothing detailed. But if at all any of you want something detailed, feel free to ask and I could share. But this is just resources to, just get you started. That's what these are. So coming to the next uh, topic, Internet of Things. And okay, before we go on to Internet of Things, I'll cover computer networks first. So computer networks is nothing but like a large interconnected network of devices. And the reason why that's important is because, I mean, the whole internet, that's how it works. And it's basically a set of computers or devices that are all communicating with each other across, common space. And again, here there are different roles such as network engineer, network operations. There are different things that come under networking. And again, cybersecurity comes very much into the picture here as well because you need to secure networks. You don't want random people hacking into your networks. And so Cisco, for example, is a very major player in computer networks. And simply put, computer networks is all about, interconnected devices. And a large scale or like a more applicative version of it is IoT. You can't really compare between those two because IoT is more like an application within computer networks. And IoT stands for Internet of Things. And I'll just put a few resources for computer networking as well in the chat. So yeah, this is computer networks. So yeah, IoT is Internet of Things, and it's about how you're interconnecting different devices. You're gathering data from different devices, and you're trying to process all that data to again get meaningful insights. And you're trying, and this again is something where there's automation and there is so for example, let's say you have a smart home that would classify as an IoT application. So let's say when you're going into a specific room, the light turns on, and as you're getting out of that room, the light turns off automatically. So how does that work? That's because there are sensors in the room which is detecting human presence. So maybe it's detecting the heat generated by your body. All of us generate heat. So maybe there's a thermal imaging sensor or thermal camera, which is, monitoring who's coming in or what is happening in that specific room. Based on that, if there's some heat generated or if there's some sort of movement, based on these two parameters, like, the lights could turn on, or maybe you have a thermometer or, a thermostat where you can detect what the temperature is in that specific room. And based on that, you could, maybe turn on the AC or turn on a fan or something like that. And naturally, where if it gets too cold, for example, you could, turn things off automatically. So these are the different applications, and that's primarily what IoT is all about as well. So again, this too, there are different perspectives, just like robotics. So one could work on the software side, one could work on the hardware side as well. And again, all this data could be sent via the internet to, some cloud computing facility where again the data processing happens, and you could even, control things from your smartphone. And so, for example, Google Home, Alexa. Um, so all these things are like interfaces that you could uh, use to control IoT devices. And but simply put, IoT is nothing but you have a bunch of sensors. These sensors are collecting data. All this data is being either transported somewhere, but some people are privacy conscious. So in that case, data could be processed locally as well. But based on all this data, some data analytics is done. And based on all this analysis, a dashboard could be shown or some action could be taken. And it could be an automated action, as I mentioned, or it could be some manual action as well. So maybe, for example, you saw someone at your doorstep, you could open the door, without even you getting up and going. So yeah, that's what IoT is. And I will share a few resources for that as well. So here are 3 links for IoT. And coming to UI UX design, this is a domain which many people are actually unaware of. So naturally, when people think of computer science, they just assume everything is just technical. But this is also a domain that is very much important because uh, it's all about that interface or that interactivity you're giving to a particular person. Because if someone doesn't enjoy a particular application or software or something, they will definitely not want to use it, because no matter how many ever features you have, unless you're presenting it well, it no one will find it interesting, right? So what is UI? UI is all about how something looks, and it's about where you like where you place things, how beautiful it looks, and basically just like some people prefer something very simple, whereas some people would prefer something very fancy. So that's why, based on the use case and based on the uh, like who's going to use a specific thing, that's how it should be designed. So for example, let's say you have someone who is in their like elderly ages. So maybe they're like some 70, 80 years old, and naturally they wouldn't have the precision of touching on a smartphone, right? So for example, if you were to design the UI in such a way that things are bigger, you would be touch or like click on things easily. And that's where this research part comes in, because UI is not about just simply designing something. It's about researching about your audience, researching about your user perspectives, and trying to design according to that. And that's also where UX comes in, user interaction, where it's all about how it feels, the overall look and feel of it. So both of these go hand in hand, where UI is all about how you're like physically placing things, whereas user experience is all about the overall experience. So for example, you could have an app that's well designed, but then maybe like the placement of things isn't correct. So that would hamper the user experience. On the other hand, you might have a good user experience, but you might not have a good UI. So, for example, people could find what they want easily, which is good user experience, but people might not have like it might not look nice. So that's why you have a bad UI. So both of these are very important concepts, and again, there's a research aspect to it, because there's something called human-centric design, where you're trying to design everything from a human perspective. You're thinking about the audience, and you're trying to come up with a UI or UX that is sorry, UI and UX that is suitable for that particular audience. This again should be done basis revenge. That's how it should be designed. So one could be a UI designer, one could be a UX designer, and these people basically work with developers to create the front end to application. So it could be a software, it could be a mobile application, it could be a web application. So wherever, whichever thing it is, you would always find some application of UI UX. So I'll put some resources for this as well. So yeah, these are a few links for UI UX. And speaking of digital media, this is again a field that is kind of related to UI UX, but not exactly. Digital media is all about the various forms of communication. So you have news, you have video editing. There are different ways of communication information, right? Again, how effectively you communicate makes a big difference. And that's primarily what digital media is all about. So from an audience perspective, you need to have the right data. It should be something very interactive. It should be something that's fun. And from a technical perspective, there are video editors who would, make sure that the video is cut properly and they would be editing the video properly. Again, you have motion graphics. You need to have the right audio, because even if you have some interesting content, but then let's say the audio is very monotonous or something, like people wouldn't feel good hearing to it, right? And so yeah, apart from that, those are like the animation or like the motion side. But it could be something as simple as a banner or a poster, because there too you need to present information the right way. And like digital media is all about communicating digitally, but again, this is also a career that you could pursue, which is closely related to computer science. And for this, yeah, I have a few resources for this as well. So these are a few resources for digital media. So coming to the next topic, app development. So these last three topics are something which the most people are aware of, and maybe many of you didn't know that the other domains existed. So that's why I have put these at the end. And app development is all about building applications for mobile interfaces, wherein you, like for example, you might be making an Android app or you might be making an iOS app. So you're targeting a mobile audience. So that is what app means. App is different from a software. A software is something that you would traditionally run on a laptop or something like that, a larger device. And yeah, so app development, again, you have the app store from where you can download stuff. You can interact with UI UX designers to come with a good user interface and user experience. And accordingly, you can like build applications for a specific use case. Again, this could be connected to other domains as well. So for example, let's say you're connected to a cloud computing infrastructure, and then your data and whatever is being loaded from that, this thing. Or maybe you're trying to make application to monitor IoT devices. So again, you have various different domains coming to the picture. So this again has subdivisions. So you could be an Android developer, you could be an iOS developer. These two are like the most prominent things. But apart from that, there is these days we have something called cross-platform. So for example, if you're using Flutter, you can build an application for both the platforms but using the same code base. There is a bit of configuration and setup that's required, but that could probably be discussed in a different session. But that's something that is there. And so yeah, simply put, that's what development is about. Again, I will share a few resources in the chat. Yeah, so these are few resources for app development. And oh yeah, before I move on to the next thing, like for Android, you have Java and Kotlin, and for iOS, you have Swift. And Flutter is something that's based on a language called Dart. So yeah. So moving on to software development, this is probably the most heard thing, although this is a term that's thrown around a lot. And even the term software engineer is thrown around a lot. So yeah, what you see on the right side is what we call the Sdlc, or the software development lifecycle, where you're trying to gather the necessary requirements for a particular application. And then you're trying to, discuss and decide how to go about building that application. And then you're trying to design the user interface. So you have the UI UX people involved there. And once that is done, the actual implementation thing starts where programmers are sitting and coding. The databases are being set up, the actual code is being written. And once you're done with all of that, again, that's where the QA people come forward and test. Or if it's automated, the DevOps people could take over. And it could be an automated, life cycle. And again, whatever releases are being shipped later on could again pass through the same DevOps workflow, and they could be released out into the market for consumers to use. And again, this whole cycle repeats. So for every version that you get, this is basically what happens behind the scenes. And this is a principle. I mean, like this cycle, it's not just for software development. Like the same thing applies to web application or the mobile application as well. But this is just a general cycle. Again, there are various different concepts under software development or software engineering, which I wouldn't go into detail at this moment because time's short. But software development, as I said, it's all about creating softwares that would run typically in your computer. And it could also mean that you're trying to develop an operating system, or it could be some software that is being run on some IoT device or some hardware. So that is the distinction between software and an app. An app is typically what you would call for your mobile applications. And although app is also a word that is thrown around a lot. So for software development, I would give you a few resources as well. And There you go. So coming to the next topic, the final topic, web development. This is something which many people find easily. So I mean, find easy to do. So usually many people who are new to computer science would start off here and then they would gravitate on towards other domains. And basically, what web development is all about, it's not just about creating websites, but it could be web applications as well. So, for example, Gmail or Outlook, these are web applications. Even Teams, what we're using right now, this is a web application. It's bounded to using something called Electron, and that's how you're using it as a desktop app. But that's again where you have the cross-platform thing. And so yeah, this is all about creating web applications, websites, and interacting with the internet. And so here again, we have different divisions. So you have front end, where it's all about what the user is seeing, what the client is seeing. Typically HTML, CSS, JavaScript. There are different frameworks and things that have come these days, such as Angular, React, Vue, etc. And on the back end, you have the server side. So front end is called the client side, back end is called the server side, where you have the databases, you have uh, the server infrastructure running. So it could be a Node.js server, for example, and it could be again hosted on some cloud computing environment, which is again sitting and processing some data or responding to client requests. So the client would send a request to the server would process whatever data, and it would send back a response. So that is how websites get loaded or web applications work. And this backend is again something that is crucial to various different things. So for example, let's say you have a mobile application. You're very limited in terms of what you can do on the device, right? And so for example, let's say you're trying to book an Uber. So you would be opening the Uber app. That mobile application would be kind of communicating with some server sitting across the world. Obviously, if it is one server, the server would just go down considering the number of users that Uber has. So that's why they are also using a cloud computing environment. And based on this thing, like that mobile application could send data to the nearest server, and it can try to make a request. And again, data has to be fetched based on where are the cars, what is the availability, which place has more traffic, what are the pricing rates, and all this data is being fetched from the server, and accordingly it is being showed in the front end. So again, the application is the front end, whereas in a website or web application, that what you see is the front end. And some people like to do both front end and back end, so that's what we call full stack. And a few common stacks that are popular in full stack development is WAMP, Mon, and Mean. WAMP is nothing but Windows, Apache, MySQL, and PHP. Again, these are different technology stacks. Likewise, you have Mean and Mern, where it is MongoDB, Express. MongoDB is a database. Express is a framework that's built on top of Node.js, and React and Angular, that's a front-end framework, and N is Node.js. So again, these are different technology stacks that you could use to build up something. And here you have web developers, you have some people are also called software engineers here too. And then again, you have people who develop content for websites. You have animators. There are different roles within web development as well. I will share a few resources in the chat window for this. So yeah, that summarizes different domains under computer science. Um, what I've given you is just a small perspective about what the different domains are. Obviously, I can't go into complete details at this week because some of you might be entirely new or hearing this for the first time. So that's why I wanted to just cover things very briefly. There is a lot more to each of these domains, which would actually take hours to complete. And especially with technology advancing at a rapid stage, there's always something new to cover. So I would really encourage all of you to, go through all the resources that I've shared. That could be a starting point. So maybe you found some domain interesting from everything that I spoke today, and you could go through the respective resources. Or if you are very curious, or if you feel that you're clueless about which one to do, you could go through all the resources and accordingly you could pick. So once you've identified your interests, then you could, explore more about that specific thing in this your first year. And accordingly, as I said, you could, work on projects in your second year. And this again, like, if any of you have any questions, feel free to ask in the chat window. I would probably be sharing a couple of more resources in the WhatsApp groups as well. So if you're not part of the group, then you can just join in the links which Sneha and Sadhna had shared. So yeah, feel free to ask your questions in the group. It could be as much as possible. And yeah, so I hope all of you got an insight or an idea about what these different domains are and like what are the different career paths and um, things you could take. Again, this is just an initial starting point, as I said. So I would really encourage you to, go through each thing and make up your mind on which ones you want to pick and which ones you want to move forward with. Because the more earlier you decide on this, then that much more time you're saving. So yeah. So feel free to drop your questions. I'll start answering them. So Samuel is asking which is more needed and future based on this from your point of view, experience in domain. Yeah, I know it depends on interest. Yeah, as you said, it totally depends on your interest, and you can't really compare one domain over the other because, as I said, like different domains interconnect with different things, right? So, for example, I can give you an example about how all these domains come together. So, let's say you're trying to um, monitor for weed or some chemicals in a pond. So what would you do there? You would try to build a robot. That robot is going to go through the entire pond and it would be, trying to collect data. And with, but then again, for it to collect data, you need sensors and everything. So that's when you have IoT coming into perspective. So you have robotics plus you have IoT, Internet of Things. And again, with all this data that you collect, you need to do some processing. You need to get rid of unnecessary data. And that's where you have data science coming into the picture. And again, if you're trying to do it for various different ponds across a particular locality, it becomes big data then. And again, it could be that some malicious person try to tamper with your data, or they try to manually come and put some chemicals just to give you false data. So that's something called false data injection, which is a cyber attack. It's classified as a cyber attack. And this is again where you have cybersecurity and things where you're trying to validate data, either whether it's at the initial source itself or while it's being transported. And again, once you have the right data, the data science and things could be done. And again, if you're trying to predict or if you're trying to do, further analysis, you're trying to predict based on a few specific parameters, that's where you have the artificial intelligence side coming up. And for all of this, you would need a lot of computing resources, which is where you have cloud computing coming up. And again, if you're trying to build a interface for people to see all the data that you're collecting, that's where you have web development or app development or software development coming up. And so you can see I've pretty much covered every single domain in this one example. So to answer your question, you can't really say one domain is better than the other. There is a future scope for each of these domains because every domain is distinct in its own ways. It's just like how you can't compare between different branches. So you can't say that CSE is better than ECE or ECE is better than CSE or any branch for that matter, right? Because everything's scope is different. So ultimately, you got to pick on which thing you're interested in, and that you'll only get to know once you start exploring something. So yeah, I did tell you stuff here, but then again, that shouldn't be your decision making point because you need to explore each of these different domains, see what you like, see what you don't like, and according to that, you can move forward with it. And one way to do it is like based on what I said, if anything interested you, go for that. Try to explore more into that particular domain. Then remaining domains you can come back to it later. Another way to look at it would be like the next domain. But at the same time, it's important to eliminate wisely because you need to understand why you're eliminating a particular domain. So that's what I would suggest for you. So yeah, no domain is better than the other. there's a future scope for everything, and even the career paths and everything are different. So, for example, I started off with web development in my fifth grade, and that I started off with HTML, and then eventually I went on to learn CSS and JavaScript and other things. Then later on, I went on to content writing, content moderation, things like that. And later on, I came back to web development. In between, I had done few things in cybersecurity, and then later on, when I came to my first year of engineering, I started with cloud computing. And in cloud computing, like using cloud computing, explored various different things such as machine learning, computer vision, um, data science, and various other things. So yeah, I too picked, I went through different domains and I tried to identify my interests. So, and finally, I've now settled down on full stack with development, cloud computing, and cybersecurity. These three are my favorite, my main interest. Although I have an interest in other domains as well. And so, for example, like last couple of years, I've been working as a freelancer and I've been working part time, mostly with it related to full stack with development, where I would create websites for people, I would create web applications for people. Some people wanted to host this on their own server on premise. Some people wanted to put it up on the cloud, and in some cases, there were some processing of data involved, and there were various different things. And once I finished my BTech, I went on to become a software engineer. I was working with Secret. I was there for about 3 months, and then finally, right now, I've moved entirely to cloud computing, where I'm working with Amazon as an operations associate. So again, it's all about how you explore. So yeah, hope I answered your question. If I want to be a data scientist, should I learn SQL or R? You should learn both because again, so you should learn SQL at the same time you should learn about what NoSQL and NewSQL is also is. So SQL is structured. It's mostly about structured data. NoSQL is about unstructured data, and NewSQL is something like a hybrid of both. So yeah, you should learn all of these. At the same time, you should learn about R and Python as well, because again, why to limit yourself? The more knowledge you have about, I mean, the better you get at it, right? So don't limit yourself. Will GDSC provide training for any of these domains? Yeah, GDSC, ACM, ACM-W, and various clubs and communities in Amrita, they would be having different sessions, and there would be different sessions coming up on each of these different domains. So, for example, GDSC has a cloud 30 days of Google Cloud program running. That's for cloud computing. Likewise, different clubs and communities would be conducting various different sessions, workshops, seminars, and etc. So yeah, you can look forward to that. At the same time, like, don't wait for people to conduct. Like, you could also sit on YouTube, you could just search online. There are a lot of resources available online. So for example, let's say any of these domains you found interesting, so you can just go to YouTube and just search for these things. So that's how you can explore, because that curiosity should come from within. And yeah, so Sneha also answered same thing. And so your opinion is having a neutral interest in knowledge. Neutral knowledge would be perfect. Not neutral, but I would say like what I meant to say was that no domain is better than the other. So ultimately, what matters is what you're interested in, and because I can't really say what might be best for you, right? Only you can say that for yourself. And how you can say that is by actually exploring the different domains. So it shouldn't be like a neutral interest, because then you wouldn't end up anywhere. But you got to pick, because as I said, you can't work in every single domain, right? That's practically not possible. So you would ideally have to pick like 2 or 3 domains out of all these. How you can do that is by reading about all of these domains, checking YouTube or various different resources about all these domains. You could even talk to people who are working these domains. So that'll give you that, career or job perspective as well. So based on the different inputs that you collect from various different people and what your interests are, you can pick like 2 or 3 domains that interest you out of all of these. And based on that 2 or 3 domains, you could, see how things go. So when you're actually working on something hands-on, it gives you an even more better understanding of whether you like a particular domain or not. So, for example, I was sitting with the development, and then later on went on to artificial intelligence and data science, as mentioned. But I didn't find it so interesting. So, but then again, that's my personal perspective. I found other domains interesting. So then I moved on from there to other domains. But I'm still familiar with that. So now also, if you ask me to do something in it, I will probably be able to do it. But again, not as perfectly as maybe someone else who's already experienced in the particular thing, right? So that's why it's important to pick what you're interested in and align yourself according to that, because there are different prerequisites and there are different requirements for each of these things, and you yourself should match yourself according to these things. So once you match yourself, then according to that, you could go towards masters if you're going towards the academic side, or you could start working on projects and things if you're going towards the career side. And next question, if one's thinking of developing an iOS application, would you recommend macOS? This one cannot. You can use an iOS emulator on Windows, but then yeah, I would definitely recommend getting a Mac itself, because okay, so for example, I think the best example I can give you is how people compare with Windows and macOS or with Linux. So that's not really the right thing to do, because you should use the right operating system for the right purpose. So if you're developing a Windows application, then use a Windows system. If you're developing for the web or something, then yeah, you can use anything. It doesn't really matter. That's your personal preference. But if you're making an iOS application or anything for Apple devices, then you definitely get macOS, because you need to use Swift and it's best supported on that. So why to deviate from that? And also, like, you can technically do stuff on other platforms as well, but it would be a big hassle. So yeah, use the right thing for the right task. So for iOS development or macOS development, definitely get a MacBook or one of the Apple devices. If you plan on doing something, for Windows or Windows development, then yeah, get a Windows system. If you're building something for Android, then doesn't matter. You can use any of them. And if you're building something that's cross-platform, again, you can use whichever interests you the most. Doesn't matter. But when you're testing stuff, then yeah, you have to make sure to test on all the different platforms, like what are you building for. So again, that would be your personal preference. If you have any questions on any of these domains or anything related to GDSC, ACM or ACM-W, you can ask. And also, some of the team members are also here. So if you wish to talk to any of us, you can feel free to unmute and talk as. Okay, so to summarize, the purpose of the session was to just give all of you an insight about what are the different career opportunities and what each different domains are about from a very brief perspective. As I said, there are a lot more details to this. There are many things not cover of time constraint. But again, I would encourage all of you to explore on your own, because the curiosity and that exploration should come from within and not by someone pushing you to do stuff. So I hope this session was useful, and I hope all of you learned something out of these different domains. And hopefully, within a few days or within a few weeks, you could identify which domains are interested, which domains you're interested in, and accordingly you could, proceed further. And again, this is a time-taking process, so don't take your time and hurry and decide on something, because you need to make a wise decision on which one you match with. Okay, Mukil is asking according to which domain pays the most. So I mean, you get paid according to your skill. So it's not which domain pays you the most. It's about what skill you have, what you bring to the table, and according to that, you would get paid. So don't go by which pays you the most or how you can make the most money out of something. That's the wrong way to think. Instead, you need to, work towards which domain is interesting to you because your interest should match. Because let's say, for example, some role is playing a lot and you're going for that particular role, even if you're not interested in that particular thing. And then what would happen is you would be, in a dilemma, you would be breaking your head. Even your employer would be breaking your head. Or even if it's a research, this thing, your co-researchers would also be breaking their head on you. So it wouldn't be a pleasant experience for anyone, right? So never go for the monetary value. Instead, look at what interests you the most, which domain is interesting to you, and where you can align yourself. So, for example, um, machine learning is not something that's meant for people who are not, good at mathematics. And likewise, there are different prerequisites and different things for each of these domains. So accordingly, you need to pick which one is best for you. So that's what you should do. You shouldn't go based on that, salary or compensation or anything like that. Because again, as I said, it's you get paid according to what you bring to the table and what is the financial background of the company. So, for example, and again, this can vary based on startups, different MNCs and things like that. Sometimes startups would pay you more, sometimes MNCs would pay you more. So it can go anyways, but ultimately what makes a difference is what is your skill set. That is what ultimately defines you. Your working experience, your experience, and what is the industry salary, how are you different from those around. So the factors that goes into. So you can't really say one domain is better than the other or one domain pays the other. So next question, any prerequisite for quantum computing? So I would say quantum computing is a very new and upcoming field. Of course, there are prerequisites for every domain. And if you're interested in quantum computing, I would encourage you to look at if looking at it from a research perspective. It's a very new and upcoming domain. And it's you need to understand quantum mechanics for it. So yeah, if you like physics, if you like building large scale infrastructure and like trying to optimize supercomputers and everything, yeah, I would encourage you to go towards quantum computing. Um, but quantum computing is ideally meant for those who have at least some understanding about what exactly it is, and they understand clearly how hardware works, how electronics is working, how modern day computers work, because quantum computing is all about taking existing infrastructure and trying to make it so much more faster, and what are the technological advancements or improvements that you can make. So rather than you using the traditional electron thing, you're using quantum mechanics principles and then you're trying to build a computer. And IBM, Google, for example, a lot of work on this. You can check out their websites if you find quantum computing interesting. But as of now, this is mostly a research domain. So if you like research, then you could, go towards that. So computers actually offer a lot of processing power, and it can like uh, drastically improve, computational capabilities. So for example, let's say you're trying to manufacture COVID vaccinations. So I don't know how many of you know about this, but there was a lot of research that was going into, the different particles associated with the virus and how different chemicals are affecting the virus and things like that. So we were using, cloud computing and like computers all across the world to simulate particles of the virus, try to find out the protein fibers and various different things. And apart from using cloud computing infrastructure, there were also other people across the world who were pitching in their computing resources through something called as distributed computing. And but then on the other hand, if you had a supercomputer, then it would be even more effective, right? Because that it can, what do you say? It can do all these computation much faster. And quantum computers would, improve that efficiency even more, and it could do things much more faster because it can simulate molecules and it can, do things at a very uh, microscopic level. So yeah, again, this is all a very research-oriented side. So if you prefer research and things, then yeah, go towards that. If you prefer more of, the um, normal job kind of side, then you can look at the other domains. So yeah, he has put up the resources, all the resources that I've shared in the chat window. Like it's consolidated in that one document. All of you can, bookmark that link or something. You can go through all these different resources and you can try to explore. What I would suggest to all of you is, just simply search for on Google or YouTube. What are these different domains? What are the different career paths? What are the different objectives or applications of these domains? And what are things that people do in these particular domains? And from there on, you can move on to the inner, the deeper level, like looking at the subdomains a particular domain offers and things like that. And at the same time, we will also be sharing a lot of resources in the WhatsApp groups. Them as well. So anyone else has any more questions? Okay, so I guess no one else has any questions, and I guess we can wrap up. So yeah, thanks for attending, and hope you all learned a lot from this. Do provide your feedback. There will be there's a feedback form that's put in the chat window. You'll also be getting feedback form via email, or to fill that up as well. And thanks for attending the session, and hope you all